direct variation. A direct variation is a relationship that can be represented by a function in the form of y equals kx. Okay, so this is our common formula. The constant of variation is the coefficient or the number before the x. Okay, so that's what the coefficient is. So that will be our constant of variation. And we're going to call this constant of variation k. So this is the number before the x. The formula that we will always use for direct variation is y equals kx. So if we're asking if something is direct variation, it has to be of the form y equals kx. So this is the key thing to remember. Y equals kx, where k is our constant. Key formula right there. Make sure you remember that. So in these first examples, we want to identify if it is direct variation, and if it is, then find the constant of variation. So this first example, we have 7y equals 2x. So in order to find if it is direct variation, so to find that, the first thing we have to do is to solve for y. Okay, and then assess the form. Does it look like y equals kx? And then 3, if it is, identify k. Alright, so solve for y. So if I'm solving this first one for y, 7 times y equals 2x. So if I divide by 7, y equals 2 over 7 x. Okay, so that's step 1. Now assess the form y equals kx. Is this of the form y equals kx? Y equals a number times x. So yes, it is direct variation. And step 3, identify k. K is the number that is before the x. So that is 2 over 7. So that is your constant. For this next one, 3y plus 4x equals 8. So solve for y. So when I solve for y, I'm going to subtract 4x to get that over to the other side. So 3y equals negative 4x plus 8. And then I have 3 times y, so I have to divide by 3. Divide by 3. And y equals negative 4 over 3x plus 8 over 3. Okay, so that is solved for y. Assess the form of y equals kx. So y equals negative 4/3 x. So if it stopped there, it would be of the form. But we add on the 8 over 3. So that means that it is not direct variation. So we are done. And we don't have to do the last step because it is not direct variation, so there is no constant of variation. Alright, now we're going to create a direct variation equation. So suppose that y varies directly with x, and y is equal to 35 when x is equal to 5. The first thing is to write a direct variation equation that relates x and y. So how I want you to read this is, so for the first one, when it says y varies directly, okay, I want you to think of it as y equals, when you see the varies part, you write equals, and then the directly part is going to say that it's our constant term times our x. So it's going to be like that, and then we have to include my 35 and my 5. So I start with y varies directly, so y equals kx, and then I put in 35 for y equals 35, and x equals 5. So 35 equals k times 5, divide by 5, divide by 5, because I need to solve for k. So that means that k equals 7. So my equation that relates x and y is y equals 7, because that's where my k is, times x. So this is my direct variation equation for this example. For part B, what is the value of y when x is 9? So I put x equals 9 into my equation, and I get y equals 7 times 9. So I just multiply that together, and y equals 63. So my answer to what value of y, what is the value of y when x is 9, is 63. Final answer. Alright, and the next example, same thing. We suppose that y varies directly. So for part A, y varies directly, so kx with x there, and y is 10 when x is negative 2. Okay, so y is 10 when x is negative 2. So negative 2 times k, this is like saying multiply, we have to solve. So I'm going to divide by negative 2. Divide by negative 2. So negative 5 equals k. And then we have to put my k in. So y equals negative 5, because that is my k, times x. So this is your direct variation equation. And now for part B, what is the value of y when x is negative 15? So x equals negative 15, and my equation is y equals negative 5 times negative 15. So when I multiply that together, I get a double negative makes a positive 75. So y is 75 when x is negative 15. And that's your final answer. Alright, now we need to understand direct variation in other contexts. So if the weight on Mars, which we're going to call y, Mars is y, varies directly with the weight on Earth, which we're going to call x, Earth is x. So, and it varies directly. So the first thing we want to realize is y equals our constant times x, where y equals Mars and x equals Earth. Okay, now the weight of science instruments on board this ship, Phoenix Mars Lander, on Earth is 130 pounds, and on Mars, they weigh 50 pounds. Okay, so I know that when Y is 50, X, because that's Earth, is 130. So now I can find K. So I put these numbers in, just like I did before, and I have 50 equals K times my X, which is 130. And now I have to solve, so I'm going to divide by 130. And K equals 5 over 13. And leave it as a fraction. So K is 5 over 13, so that means that my equation is Y equals, or Mars equals 5 over 13 times my X, or my Earth weight. Okay, so I have that as my equation. And now for the second part of the question, if the ship's commander weighs 175 pounds on Earth, how much does he weigh on Mars? So I need to find X. Earth is 175. And then I need to find Y. So I put it into my equation. Y equals my K, which is 5 over 13, times my X, which is 175. So I just type that into the calculator, and you would get about, similar to, 67.31. So that means the weight of the commander is 67.31 pounds on Mars. So that would be your final answer. Alright, so now I have the same situation, I just want to graph it. So I'm going to graph the situation if the weight on Mars varies directly with the weight on Earth. And we figured up that our formula was Y equals 5 over 13. So we want to graph that formula. So when I'm graphing the formula, what I'm going to do is I'm going to just number off. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, and so on. And then I'm going to go up. 1, 2, 3, 4, and so on. Now when I'm graphing this, because we have nothing left over, and because it's direct variation, we're always going to start at 0, 0, and then our line's going to go through that point. So if we remember from our rate of change is going to be the 5 over 13. Okay, so that means my rise is 5. So I'm going to go up 5. 1, 2, 3, 4, 5. And then I'm going to go over 13. So my run is 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then I just draw a line between the 2 points. And it continues on. So that is, and I'm not actually going to go negative because you can't have a negative weight. So my graph is going to look like that. So you use your rise over your run, which comes from your fraction, rise over run. And there's your graph, and you're done. You should label things, though, if you can. So this is our X, which was Earth. So this is weight on Earth. and this is your y, so that would be your weight on Mars. So you should mention that as well. Those are in your notes over direct variation. Go through the practice problems, make sure you're comfortable with all these different types of problems, and then you can take your quiz.